So if the probability of event E and the probability of event F are both 3/4, and the probability of E complement intersect F complement is 0, find the probability of E intersect F. Okay? Now, just before we actually get into this, while we are using sort of intersection and complements and our usual operations when it comes to sets, it's important to remember as we start studying probability to think about events as collections of possible outcomes to our experiment, things that can happen. So instead of saying the probability of E complement intersect F complement, what we might say is something like the probability that E does not happen and F does not happen. Just sort of some thoughts that we can have there as we try and start to interpret this. Because I find math is a lot nicer when we actually have some meaning to it rather than just it's a collection of symbols and operations. But let's take a look here. So we know both E and F have the same probability. We might call them equiprobable. Okay. And E complement intersect F complement equals 0. And we want to know, well, what's the probability of E and F both happening? Okay, that's the way we could read and interpret that. So because we don't have a word problem, we don't really have a scenario here, we have to rely on our knowledge of formulas and our ability to calculate. So I might start to think, are there any formulas involving probability that I know of that use an intersection? And there's 2 of them, and they're very similar to the sort of formulas that you used to see when it came to sizes of sets. They're almost the exact same thing, except they've got some square brackets and they've got some PRs, but that's about it. So just as soon as I see, I want to calculate this, I think, are there formulas with it that I know? And yeah, there's formulas like this one. Okay, where the chance of E happening is the chance of both E and F happening plus the chance of E happening but F not happening. So that's one formula that involves intersection, and then there's sort of this other one. Okay, probability of E and F both happening is the probability of E plus the probability of F minus the probability of E or F happening, or maybe both. Okay. And these probability formulas and the set size formulas we had originally, they all just relate to the way sets are put together and the way our operations are defined. We don't need to go too deep into them. But calculating E intersect F, which one might I use? Well, it depends on what other information you've got. Okay, so for this first one, I would need to know the probability of E, got it, the probability that I want, and then E intersect F complement. We're close, but we're not quite there. And that would be E complement intersect F complement. But we could find a way to use this one. Okay. Or we might say, well, maybe I need to use this second formula here. Okay, probability of the intersection, the thing that I want. Probability of E, well, I've got that. Probability of F, well, I've got that. The union, well, I don't have that. So then we sort of run into these challenges. And you can actually use either formula to get it. What sort of immediately strikes me with this one is this extra piece of information, the E not happening and F not happening. I know that that's 0. Okay? But I've seen E complement intersect F complement way, way earlier in the course. Okay? This is a De Morgan's rule. It's the complement of E union F. E or F not happening. Neither E nor F happens. Okay? And so when I see that, I say, oh, okay, so they've just been sort of sneaky and gave me this bit of information. Now, I'd really like E union F. I'd like the probability of that. I have the probability of its complement, but here's where we remember another formula. Probability of a complement is 1 minus the probability of the non-complemented thing. So I know that this is 0. 0 is 1 minus what? What do I take away from 1 to get 0? 1. Okay, so now for this formula, I know all 3 parts, and then I can work out E intersect F. Right, probability of E plus probability of F minus the probability of their union. Okay, so I could make that 3/4 plus 3/4. I could change 1 into 4/4. Total of 6/4 minus 4/4, 2/4, or just 1/2. Okay, so that gets our answer. But of course, that's not the only way to do it. So let's look at just a different way to do this question centered around this formula. Okay, we're going to use that one a whole lot. So I'll copy down my information again. Because it's always good, if you can, to figure out different ways to do the same question. It improves your understanding, your different perspectives on the material. Okay. So, what could we do? Well, I could say, I would like the probability of E intersect F. Now, I know that if I also had the probability of E and F not happening, that those two add up to the probability of E. Well, I know this. This is 3/4. So if, and it's a big if, but if I knew this, if I knew that this was, say, 1/5 or something like that, I'd be able to solve for the one that I do want, the probability of E intersect F. So if I could just work out this, in the same way that the first time we did this question, if I could just work out E union F, we had to do a little bit of extra work. Okay. So now I think, all right, I would really like the probability of E intersect F complement. If only there was some way to find that. Well, if I also had, say, the probability of E complement intersect F complement, that would add up to the probability of F complement. Same idea, same sort of formula, just instead of instead of E, we're working with F complement as our special set. Right, so this is another approach. Now I know this. This is 0. Do I know F complement? Well, no, but I know F, so F complement should be 1 minus the probability of F. That's 1 minus 3/4. So the probability of E intersect F complement plus 0, we'll just drop that, is going to be the same as 1 minus 3/4. That's 1/4. So now I know that this is 1/4. So what plus 1/4 is equal to 3/4? 2/4, or 1/2. And we get the same answer the same way. I went a little quicker with this one here.